Okay, anyone just unable to say that what is the last topic sir I teach you in the class? Anyone? Any students can able to say what are the last topic that they teach you in the class? What are the last topics sir I teach you in the class? Aditya and John, Avni, Breeze, Darshit. Did the sir had completed the ALU operation, arithmetic and logical unit both? Did sir had completed the ALU? Okay, the shift operation. The shift operation. If the shift operation is completed, okay. So the last, I think we need to discuss about the questions, the exercise, the problem statement we have it. Okay. Okay. Let us just say I had already shared my screen. Just give me a minute to go to that slide. Okay. This operation is clear, all of you. If the screen is visible and the voice is audible, all of you. If the screen is visible and the voice is audible, all of you. Okay, good. So, what is this operation? Do you know or not? This thing. You know about this, I think so. So this is a control logic. What do you mean by the control logic? Anyone? What do you mean by the control logic? That the data will load from R1 to R2 depends upon the clock also. And what is that control logic? Let's suppose if I write like this, P, then R2 to R1. What does it mean? What does it mean? Anyone? What does it mean? If when the P is equal to 1, the data is loaded in from R1 to R2. Very good, Dhruv. Okay, so why I said that, because while solving the problem, you understand this thing. Okay, this is what the first problem statement they had asked in the exam. So a digital computer has in common the system 16 register of 32 bit each. That the sir had covered this part or not? So the Vishal sir had covered this part. The first question. Yes, Dhruv, Sunita, Aditya, Riya. The sir had covered this first question or not? Because such kind of the questions they are asking in the exam. That covered these things also. Okay, so what about this question, Sunita, Mitali? This question is remaining. Okay, good. So previous one was, that was a very easy to understand. Okay, Mohammed says fine. So this is also a kind of an questions what we have. So this is the y into t2, that are the two variables. Depends. So this is what we call as a control logic. This is what we call as a control logic. And depends upon the control logic, this operation should be performed. That means if the control logic output is equal to 1, R1 should go to the R2, and if it is 0, R2 should go to the R1. But remember one thing, you cannot able to use like this, because here we have the two variables. Okay, so you need to use a different technique. So use your pen and paper and just try to draw it by yourself. The logic gate implementation is very easy. I need a 2 register, that is confirmed. Which are the 2 registers? So these are the 2 registers I required, R1 and R2. Both register are working on a clock. So what I'll put a clock. I'll put a clock. So what happens, at each and every positive edge of clock pulse, this data will be loaded. Okay. Now R1 should go to the R2 and R2 should go to the, let me use a different color. Okay, so R2 should load to the R1. But what should be the control logic over there? How I should implement y into T2? Which gate I will use? AND gate. Okay, so I will use one AND gate, from which I will generate a load signal y and T2. But what happens if I directly give here this signal, and this is nothing but a load signal, both of them. So when this one, what actually happens, there will be one conflict will be present over here. R1 data will go to the R2 and again R2 data will come to the R1. So both the things are executing at the same time. We don't want that. So what do we need to do?
Sir, XOR?
No, not an XOR. Let's suppose what I actually see. The question is, according to the question, the diagram, what you are looking at over here is correct. But what I need, this, when it is a 1, this thing should happen, and if it is 0, this thing should happen. So at a time, either the data should go R1 to R2 or the data should go R2 to R1, not at both the register at the same time. What should I do? If I'll put a one NOT gate over here, then the problem will be solved. Yes or no? That means if it is 1, this will be 0. So the data will go from R1 to R2 only. No data will go from R2 to R1. If it is a 0, this will be 1. That means the data will not go from R1 to R2. The data will go from R2 to R1. Is it clear, all of you? Is it clear? Okay. But
Yes,
according
sir.
to this question, we need to do the same thing at a time. Okay. But this was like, I had just modified the question. So according to this question, what they had asked, this architecture is clear. That means at the first clock pulse comes and the load signal comes, that means this both will active at a time. So during this clock pulse, this data R1 clock pulse, the data will go to the R2, and again R2, the data will come to the R1. So this data have not the same data. R1 data will be pushed to the R2 and R2 data will be pushed to the R1. Okay, so they have the two different data in the register. So at the same time, both the registers are getting loaded. So this diagram is correct for that. okay, according to the block diagram what is said. Now coming to this point, the question what the displayed in front of you is very large. The solution is very easy. What actually is telling, there are three registers are there, R0, R1, R2 and R3. Now they are connected to the 4:1 multiplexer. You know about the 4:1 multiplexer. And to the input of the fifth register, R5. So what happens, what actually is telling that I have the multiplexer. In the first multiplexer, I had connected R0, another connected R1, R2 and R3. And this is the nothing but a data which is one of the data is going to the other register, that is R5. But that will be used using the selection line. So if it is 0, 0, R0 data will go to the R5. If it is a 0, 1, R1 data will go to the R5 because it's a 4:1 multiplexer. So output must be any of the one input. Okay. So that is what the first term. But what they added here, okay, so now they had added one more thing, that the data directly won't go to the R5, R0, R1, R2 and R3. It goes depends upon the timing. That means, let's suppose if I have this clock pulse or a signal, so this is the T0, let's suppose. So when the T0 is active, then and only then selection line should get 0, 0 and the R0 should go to the R5. If it is T1 signal is coming, at the time T1, your selection line should be 0, 1 and the R1 data should go to the R5. If it is a T2, then selection line should get 1, 0 such that R2 will go to the R5, and at the time T3, the selection line should be 1, 1 and your R3 data should go to the R5. Till this, the problem statement is clear. So what are the things you required? First of all, you required a register, you required a timing variable, and you required the selection line. Till this, is it clear, all of you? Yes, Dhruv, Mohammed, Faiz, Itali. Explain the timing diagram. Timing again. Just see here. Let's suppose this is the multiplexer. I am giving you the 2:1 marks, okay? The R0, R1. Two registers are there. There are the only required one selection line. So I am taking the one selection line. Let's suppose this is selection line. And this is the output what I need, and it should be loaded into a R5 register. So what I mean to say, so when this T0 gets 1, this is a T0 and here it's a T1. I'm explaining this two only, T0 and T1. At the time T0, what happens? Your selection line, when this get 1, your selection line should get 0. So if the selection line 0, that means this is a 0, 1, this is a selection line. If this will get 0, R0 should go to the R5 because the selection line is 0. After that, when it reaches to the T1 time, this should be changed with a 1, and when it changes to the 1, R1 data will go to the R5. Okay, this is what the timing diagram. Dhruv, clear now?
Yes, sir.
Okay. What are the extra things they had wrote? Let's discuss that also. The timing variable are mutually exclusive. Timing variable. These are mutually exclusive, which means that only one variable is equal to 1. At a time, only one variable. T0 if it is 1, rest of them are 0. If T1 will be 1, rest of them will be 0. While other of the three are equal to 0. Understood? So draw the block diagram showing the hardware implementation of the register transfer. Include the connection necessary from the 4 timing variable to the selection input of a multiplexer and to the load input of a register file. Okay. Now, just for 5 minutes, think about the block diagram. Try to draw by yourself and then we'll discuss this thing. Here you require the concept of the K-map. Okay, any student have any idea that how to approach to the problem statement? Yes, any student? Okay, so all of you knows the K-map concept? All of you knows the K-map concept? Let's suppose take an example of an AND gate. I have the A dot A and B two variable and the output Y. So 0, 0, 0, 1, 1, 0, 1, 1. I'll let output like this. So what is the Boolean equation of this AND gate? What is the Boolean equation of the AND gate? What is the Boolean equation of the AND gate? Yes, the A dot B. And how you got? Either you can write like this, go for the K-map. Okay, like A, B, and fill this table like 0, 0, 0, 1. And if it is SOP, this is the B and this is the A, so it's A dot B. This is how you write. But let's suppose if you want it directly, without using this K-map, you can write it down directly also. Let's suppose here, look at this. Where exactly we are getting 1? At this. What is that? A and B both are 1. So obviously, and there is only one is there in output, so it's always be A dot B. Okay. Take an example of other thing. Let's suppose, let us take an XOR gate. A, B, Y. So 0, 0, 0, 1, 1, 0, 1, 1. So this is what the output? Yes or no? The XOR gate, the output is this one. Is it clear, all of you? How many ones we have at the output? There are only 2 ones. Which are they? Here I am getting, and here I am getting the 1. So try to write down the Boolean equation for this first one. What is this? A is 0 and B is 1. So wherever the 1 is there, you write down as it is variable. If it is A is 0, you write down the A bar. Write for other term because it's SOP I am writing. So product and then sum of product. Okay, let us write for another one. What is this? 1 A dot B bar. Directly without using the K-map, you can write like this. Okay, let us suppose one more example we'll take. X NOR gate. You know the Boolean equation, but directly how you can able to write, that is what I am teaching you. So it's a 1, 1 and 2 of them are 0. Let us write for this. What is this? It's a bar dot to B bar, because both are 0. For other term, add plus, write down the product term. What is this? A dot B. It is clear, all of you? The things is clear directly? Okay, now we'll try to solve for this. That is confirmed. Don't use this. We'll use this space to solve the previous problem. Okay. So I have this, the multiplexer. That is a 4:1:1. R0, R1, R2, and R3. There is a one register that is nothing but we call as a R5, which is connected to the output of the multiplexer. There are the 2 selection lines, S1 and S0. Here there is a one signal always be there, CLK. With respect to clock only it will load the data. I need to generate one more signal we call as a load signal. Till this signal generate, you cannot able to load any of the data to the R5 register. Till this the diagram is clear, all of you? Till this the diagram is clear? Any doubt till this diagram? Any student? Yeah, that is what signal we are generating, Sunita. That is, I'm going to teach that how you can able to generate a load signal. Dhruv, that is what I'm teaching. But till this, the diagram is clear, all of you? Dhruv and Sunita. Okay. So what I'm doing, I'm just need to use the space here. Now to generate the load signal, how many input variables we have? Anyone? How many input variables we have? T0, T1, T2, T3, R0, R1, R2, R3. Selection line is also input. That means I'll write over here the T0, T1, T2, T3. 2 selection line. S1, S0, which is the output signal I need to generate, and that is a load signal which I need to generate. If it is 1, rest of them are 0, which data should go to the R5? R0 data. Now, using the which selection line should I get R0 to the R5? Selection line 0, 0. So here I'll write a 0, 0, and I will generate a one load signal. That means if the T0 is 1, selection line is 0, 0, R0 data will go to the R5. Is the first terminology is clear, all of you? Yes, correct. Through what you wrote is also correct. But till this, it's clear, the first terminology. What I mean to say, how to generate a load signal. Sunita? Okay. Now, when this 0, this is 1, 0, 0, 0 and 1, that will select your R1 to go to the R5. So that is why I wrote the 0, 1, and R1 will go to the R5 when the load signal is generated 1. Same way you can write like this. Is it clear, all of you? The truth table is clear, all of you? If the truth table is clear. So what is the selection line for S1? These are the two ones. So S1, the selection line, because the load signal is generating all the time, so we don't have to worry about the load signal. But what is the S1? That is when the T2 and T3 is 1. So I can write directly the T2 plus T3 is 1. What about the S0? This one and this one. So it's a T1 and this one is a T3. So T1 plus T3. Now coming to over here, let us write it here. So once I need an OR gate where the line of T0 will go, where the line of T1 will go, where the line of T2 will go, and where the line of T3 will go. So S1 should connect with the T2 and T3. So S1 should connect a T2 and S0 should connect to the, sorry, I need to add one OR gate over here. Okay, I need to connect one. So consider this is a OR gate. T2 and T3, when it gets 1, at that time only S1 will get 1. And what is that S0? T1 plus T3. So again I need a one OR gate. T1 and T3. Okay, the load signal will generate all the time. Whenever the T0, T1, T2, T3 will come, this will always be there. So this diagram is clear, all of you? Any doubt in the diagram? Any doubt? Yes, any student have not understood, please ask. Suchi, Nita, Dhruv, Nisargi, Mohammed, Jan. Is it clear, all the students who are joined in this class? Okay. No doubt, correct? Okay. Finally, we'll go to this question. It's a control logic. I had given the program in terms of code. Okay, you need to draw a register transfer statement. That is the statement what we are writing. We are writing like this. Same thing you need to write. Okay, so read the program and try to write it down the answer for the same. Okay, good, Dhruv. What about the else if condition? Dhruv, can you explain this terminology? Why you mentioned the queue over there? Why you didn't mention the queue on the first program? Yes, Dhruv, can you please explain to other students why you didn't mention? What do you mean by that, Dhruv? My question is why you mentioned the queue in another term? Why you didn't mention queue in the first term? You wrote as a P semicolon R1 goes to R2 goes to R1. But in second, you wrote as a P dash Q. Why you didn't mention the Q dash over there? Yes, Dhruv. Just because when P equal to 1, then only the first part will come. But when the P equal to 0, then it will else part. Very good, Dhruv. That means what he had understood, that is also correct. The P equal to 1, when the P is equal to 1, at that time I need my R2 data should go to the R1. And else if is there. Okay, there is no only else, it's else if is there. So you need to consider the P dash also and the Q. At that time, the R3 will go to the R1. Very good. Okay, this is what the answer. So look at the answer, and still if you have any doubt, let me know. Okay, is it clear? Okay, now the next question, this one. This is the control logic. This is the operation we need to do. But remember, this plus, it's a OR operation, and this plus is a summation. So based on that, obtain the control logic, obtain the block diagram. Okay, let's give the answer for the same. See, all the students, I'm asking again, if you have any doubt, you can ask me any questions. Okay, so I try to explain you like from the very basic things, and still if it is look like I don't understand anything, just drop me a message in the chat box so that I can able to know that whether you want to learn again or not. Yes, any students? What is the logic we'll apply for at least this x plus y into z? Which are the gates we'll get? Yes, the AND gate for X and Y, and it's output very good through. So what I'll do, I'll take one AND gate, and there I'll give Y, I'll give Z. Output of this will be given to the OR gate, and that is X. Now that will generate a load signal. Where I need to load it? We need to load it in AR. This is the AR. But now addition should be performed. So I need one adder. This is an adder. This is an adder. We need to add two things. One is AR. Okay, the AR will go over here. It will add. What is the another things need to add? That is a BR. So I need to take one more register. That is a BR, and that should be added over here. So AR and the BR from here will be added to the adder, and the output will go to the here. But it will load the data till only the load signal will generate. Okay, is it clear, the diagram? Look at the diagram one more time, and still if you have any doubt you can ask anything. Okay, so that is what I added, the clock signal. This is the whole diagram with including the clock also. Solve for this. This is the which circuit we call this? What is this circuit name? and that is what we also call as a universal adder and subtractor circuit. Okay, so what happens over here? See, this is the M. Signals goes to the each and every XOR gate, all the input. Okay, and rest of the other input like B3, B2, B1, and B0 is going to this XOR gate. So when I draw like A and B, but suppose here we have the two inputs, their name is M, B, and Y is output. That is XOR gate is like this. So what is the output I will get? This is what the output I will get. Why we use the XOR gate over there? Look at over there. When M is 0, the value of B might be 0 or 1. The same output I will get at output also. But when the B is equal to 1, what is the output? 0. If it is B is 0, output will be 1. If B is 1, output will be 0. That means I can say here I am getting output B when M is 0. But when M is 1, what is the output I am getting? The B bar. Clear all of you? So that is why during subtraction we need B bar plus 1, that is the 2's complement of that number. Now here it is given like this. So when M equal to 0, you need to do the addition of these two numbers. When M equal to 1, you need to do the subtraction of this number. And then you need to write what should be the sum and what should be the carry. Okay, so write it down, the answer. It's very simple questions. Okay, directly just addition and subtraction, that's all. Okay, now let us start with the first addition term. You know what the addition when you are doing this number and this number? What should be the sum and 0? Like 0, 1, 1, 1 plus 0, 1, 1, 0. When you do the addition, the 1 plus 0, 1. 1 plus 1 is a 0 and 1. 1 plus 1 plus 1, so it's a 1 and 1. So 1. So output of this will be, sum will be 1101 and carry is 0. Okay, and that will lead to the 13 number what the Dhruv had wrote. Again the 1000 plus addition of 1001, and do the addition, which is 0 and 1. So sum will be 0001 and the carry will be 1. What is the important task is over here is the subtraction. When I ask you to do the subtraction 1100 minus 1000, that means you have to convert this number 100 into 2's complement, because you know that the subtraction, if you want to do the subtraction using the addition block, we always write like this. We can write like this, and if you can write like this, this is a negative number, so represent it into a 2's complement form. So if I need to convert the, sorry, it's not a 1100, it's a 1000. Okay, so now what I can do, convert this number plus 1, what I'll get? And the 1, the same number I will get. So let us now try to add the 2's complement number to this number. So it's a 1100 plus 1000. What is the output I will get? I will get a 0, 0, 1, 0, and this carry is 1. In the 2's complement, you know that we actually neglect the carry. In a 2's complement, we neglect the carry. So that is what is the answer we got, and the number answer what we got, and that is the true answer. So we'll get 4 as the answer. Okay, the sum is a 4, carry is still 0. We got a carry, but here the sum is plus 4. Okay, we ignore this carry. Okay, clear? Now this two, I request you to do at a homework and tell me the answer, not me, the Vishal sir as the answer. Okay, fine. So we conclude the lecture over here, and still if you have any doubt in this question what we had solved, and ask a question. The answer will come in the positive or negative? Dhruv, 1011 or 1111? Negative. Okay, good. So all of you just write it down, this attendance in a sequence. Okay, don't write it randomly. Write it down in a sequence, and then once you wrote the attendance, you can leave. Okay.